Hello everyone, I am Aditya Sauri. Today our topic is heap tree. A binary heap is a complete binary tree which satisfies the heap ordering property. The ordering can be one of two types: minimum heap property and maximum heap property. In minimum heap property, the value of each node is greater than or equal to the value of its parent, with the minimum value element at the root. In maximum heap property, the value of each node is less than or equal to the value of its parent, with the maximum element at the root. So to construct heap tree, we have to follow complete binary tree property. So at all levels we have to fulfill, and we already know what is complete binary tree. We already discussed this thing in previous videos. So to construct a heap tree, we have to fill all the nodes from left side only. So we can discuss the thing in an example. And we have two types of heap trees. One is minimum heap tree and maximum heap tree. For minimum heap tree, you can see here the diagram 6, 7, 12, 10, 15, 17. Here root node will be the minimum value. So in this way we have to construct this tree, and it is called as minimum heap tree. And for maximum, the root node must be the maximum value compared to the child nodes. So we can discuss with examples also. In a heap, the highest or lowest priority element is always stored at the root. Hence the name heap. A heap is not a sorted structure and can be regarded as partially ordered. There is no particular relationship among nodes on any given level, even among the siblings. Since a heap is a complete binary tree, it is the smallest possible height. A heap with n nodes always has 0 log n height. A common use of a heap is to implement a priority queue. Now let us take one example and let us discuss how to construct a maximum tree, heap tree and minimum heap tree. Now let us discuss how to construct a maximum heap tree. So here I took some elements 25, 23, 32, 20, 14, 19, 27, 34, 26, 21, 9. And the basic property is we have to follow complete binary tree property. So we already know what is complete binary tree. So we have to fulfill all the levels. That means we have to follow 2 power L. Here L means the level. So starting root node will be the 0 level, after that 1 level, after that second level. So in this way we have to follow the property of complete binary tree. So now let us discuss how to construct. Okay, the first element is 25. So we have to take this 25 as a root node. After that we have 23. After that 32. So we have to fulfill from the left side only. Now we have to do comparison. That means we have to find the largest element of this child node, 23 and 32. So here 32 is the largest element. Now we have to do comparison for the largest element and to the root element. Okay, here 25 is less than 32. So in maximum heap tree we have to give the largest number in root. So here the condition is not satisfied. So after that we have to do swapping. That means here 32 will come, here 23, and here 25. So after swapping the tree will be formed like this. So now we can check, compared to children the root node is the largest one. So here the condition is satisfied. After that we have another elements 20 and 14. So 32, 23, 25, and we have to come from left side only. So 20 and 14. So after finishing the left node we have to enter new elements to the right side to follow the levels. So now we have to do comparison of children's. So here 20 and 14, compared to these elements 20 is the largest one. Now we have to compare with the root element. So here 23 will be the root for this subtree. So here the condition is satisfied, so no need of swapping. After that we have another two elements, one is 19, another one is 27. So after that we have to follow the same rule. So compare it to 19 and 27, 27 is the largest one, and we have to do comparison for the root node. So here 25 is the root node for this subtree. So 25 less than 27. Now we have to swap here these two elements. So after swapping the output will be like this. So 32, 23, 25, sorry, here 27 will come, here 25. Now we have to repeat this thing again, because maybe here okay, sorry, no need of repeat this logic. So now we can check the subtree again. So compare it to parent and children's, here 27 is the largest one, so no need of checking. After that we have another values, that is 34 and 26. So again I am using 23, 27, so after that we have two values, that is 34 and 26. So compare it to 34 and 26, here 34 will be the largest element. After that we have to do comparison for the root node. Here 34 is the largest and 20 is the smallest, so we have to do swapping here. So after swapping, here 20 will come, here 34 will come. After that we have to repeat this condition, because compared to this root, that means 23, so 34 is the largest and 23 is the smallest. So here we have to again swap the elements. After that here 34, 32 we have to do comparison, and 32 will become the largest element compared to 32. So here also we have to swap the elements. So after finishing all those things, actually we have to follow this step by step, so but here I am telling directly. So first 34, 32 is changed from as a root to child 27. Here we get 26 because here also we swap the elements. After that 20. So after finishing these swapping, here we get 20. So for that only we swapped the elements here. So here 19, 25. So in this way each element will be swapped. After that we have another element, that is 21 and 9. So we have to place this 21 and 9 here. And 9. So we have to fill all the elements in a order. That means we have to use complete binary tree property. So we have to fulfill all the elements in level wise. So here we can see, compare it to 19 and 21. 21 is the largest, so we have to swap the element here. After compare it to 21 and 27, 27 is the highest and 21 is the smallest, so no need of swapping. So we have to swap in 19th subtree level only. Okay. Sorry, I did a mistake here. Sorry, I draw wrongly. Actually, I forgot another. So for 32 we have 2 children, but I draw only 1 children. Sorry for that. 20, 23. Okay, I'm giving, sorry, 14, 25. So after that we have here 14 is there. Here 19. So now we have to store. So after inserting all those two elements, last two elements 21 and 9, this is the maximum heap tree, but we have to do comparison here. So compare it to 21 and 14. 14 is the smallest element. So according to our rule, parent node must be highest. So for that we have to swap this thing like this. So after swapping, the total tree will become like this: 34, so by using all those elements, in this way we can construct the maximum heap tree. So I hope you understand this topic. Now let us see how to construct minimum heap tree. So here I took some elements to construct a minimum heap tree, that is 24, 26, 31, 25, 14, 18, 29, 35, 27 and 32. So here also we must follow complete binary tree property. And what is minimum heap tree? So we have to make a minimum element as a root node. After that we have to do comparison. So in that way we have to construct. Now let us see how to construct. So here our first element is 24. So here I am taking 24 as a root node. After that we have element called 26 and 31. So we have to do comparison for the children's 26 and 31. So to find the maximum element, we find maximum element in children position. But now we have to find the minimum element. So we have to find the minimum value in children positions. So here 26 is the minimum value. Now we have to do comparison with the root node. Here 24 is the root node. Now we have to check which is small. So compared to these two elements, 24 is the smallest element. So here our condition is satisfied. So here root node is the smallest element compared to 26 and 31. After that we have to insert two elements. So 24, 26, 31. After that two elements is 25 and 14. So we already know we have to follow from left side only. So compare it. Now 26 is the subtree. So we have to compare the children's, that is 25 and 14, and compare it to these two elements. 14 will become the smallest element. So we have to do comparison with smallest value and the parent value. So here 26 is the parent. So compare it to these two values. 14 is the smallest element. So we have to do swapping here. So after swapping we will get this thing. So 14, 25. So in 14 place I am sending 26 value. After that 31. Now again we have to run a loop again, because here 24 is the largest compared to 14. So here also we have to swap the values. So 14, 24, 31, 25 and 36. So in this way the minimum heap tree is formed. After that we have another elements. Those are 18 and 29. So compare it to all these elements. Here 18 is the smallest one. So we have to swap this thing. So we already know how to comparison. So first we have to compare parent nodes. After that we have to find the minimum element of the children's. So after that we have to do comparison for the parent and the smallest child node. So if the condition is satisfied we have to swap, otherwise no need to swap. But here condition is satisfied, so that's why we are swapping here. So 24, here 18 will come because we swapped that thing. So here 31 will become and 29. Okay. After that we have another elements 35 and 27. So 35 and 27. So compare it to 35 and 27. 27 is the smallest element. So now we have to do comparison with the parent, that is 25. So compare it to parent, 25 is the smallest element. So no need of swapping. After that we have another value, that is 32. So we have to insert this 32 in the left side, not in right side. So no need of space. So after inserting all those elements, the final output is 14, 24, 18, 25, 26, 29, 35, 27, 32. So in this way minimum heap tree is formed. So now let us check. So compared to this subtree, 14 is the smallest, so that means minimum. So compared to this subtree, 24 is the minimum. Compared to this subtree, 18 is the minimum. And compared to this thing, 25 is minimum. And compared to this subtree, 26 is minimum value. So in this way we have to satisfy all the tree and subtrees. So when compared to entire tree, here 14 will be the smallest value. So in this way we have to construct minimum heap tree. I think now you understand how to construct a heap tree, that means maximum heap tree and minimum heap tree.